Hi, everybody, and welcome to our Cloud Metro session now. And probably going to talk about a little boring thing, old school networking, no more applications and services. But though those networking are pretty much driven by requirements which are coming from those new class of applications. And yeah, I'll try to stick with the title of this presentation. We'll talk about the cloud principles which can be applied to the metro to transform it, which is under pressure of those 5G, rise of 5G, and actually the influence of different types of new class of applications and content which are placed in the locations in the metro where it never have been before. And in general, that requires to transform the traditional metro, where it is just a maybe dump pipe created in the first place to transfer traffic north-south, so into something more sophisticated, more organized, which allows to serve more complex traffic patterns, importantly, sustain the huge traffic growth, which is driven by the 5G to a large extent, and also, which is another important thing, to connect applications, or maybe, we can have services which provide applications at any literally location of those metro infrastructure. So that's one trend. The second trend is actually virtualization of the network functions of the transport infrastructure itself, of the network itself. And this is something we see that happening all across the place. And 5G is the brilliant example with all the virtualized CUs, DUs, virtualized evolved packet core, which in the context of the X-hole will be placed all across the network from access to the more central locations. And in fact, it's happening in other places. Cable is another example. So those guys are trying to digitize their R5 function, also virtualize CMTS, traditional broadband aggregation. So that's where the former monolithic BNG transforms slowly towards the newer CUPS models with disaggregated BNG control and BNG data plane, right? And now we can take it and drop it in any place of the metro. At least that's the intent. And the point here that many of those virtual functions already now coming in the form of the cloud native applications. And of course, they're coming with the thought behind that, okay, so we can move them freely and orchestrate them as flexible as we do orchestration of the services and applications in the cloud. And even so, where we're moving application from one cloud to another. And if we think about why the concept works so well for the cloud, it's pretty much for the fact that the cloud is based on the very well thought data center fabric, whereas well separation between the underlay and overlay tunneling, which in its turn based on the close-like topology, which is relatively simple, or at least well understood, right? And that's what creates the foundation for freely moving those applications all across my infrastructure. So the first concept which we can actually implement for the metro is about this, converting the highly segmented and siloed metro infrastructures towards the end-to-end IP service fabric, right? So here we probably not talking about the converting the metro into gigantic closed topology. So the metro will have still lots of inertia, and there's some economical reasons why all types of topology will contain to stay in metro. So rings, partial mesh, etc. But the key building block of the metro, so the routing system, which independently of its size and amount of terabytes it's capable to put through it. So it should provide the same set of networking capabilities, which allows to enable the function of the IP service fabric at any location. And if we double click on more or less common example of how the metro network looks like for the service provider. So we see these kind of layers, access, aggregation, metro, services and services on the top, multi-service edge at the top with access which interconnects our terminals. There might be cell towers, business customers, some residential customers. And at the very top, that's where the metro meets the other part of the network infrastructure of the service provider, would be WAN, Internet Public, and essentially telco cloud. So that's the type of network which we can see today. And the transformation would happen with the first step when telco cloud moves closer to the access, right? So with that, we're also transforming the aggregation layer into something we call the lean edge. So the lean edge function will be provide all the same L2, L3 VPNs, which we know for now. So it will enable immediately the east-west traffic patterns. It will enable the low latency services. The application can be placed in this telco cloud infrastructure. With respect to the existing multi-service edge, we believe it stays where it is for quite some time. It allows a smooth transformation from the older to the new network architectures. And it will serve for some corner cases where we need to stitch some VPN services which are not stitchable just with the use of the lean edge platform, because lean edge is a lean edge, so it still comes with some restrictions, all right? And in the next step, what will happen is just we'll need to scale out the telco cloud infrastructure by placing more applications, by terminating more traffic streams at this location, and also to scale the part of the aggregation network. And here, as a matter of fact, we'll see the rise of the type of closed topologies, because the let's say scale-out approach is very much applicable for this one, but still will be restricted by the location of a particular central office or maybe a point of presence in the network. And the very last step is moving the compute edge to the very down in the access. Right, and here we see a couple of interesting applications specifically coming from the area of the 5G networking, and specifically virtualization of the cell-side router function of the network infrastructure itself, and placing into the compute node sitting next to the VDU, for example. So we believe there are really advantages from the total cost of ownership in some dense 5G deployments. And the statement here is, we can see that the metro meets the element of the telco cloud practically in every point of this network infrastructure. And here, where we're talking about that the metro becomes the new service edge of the service provider network. And so far, so good. So we've built our IP service fabric. The only drawback of this thing is the relatively high complexity of the network which we facing over here. It is higher than what we would expect. Some simplification of this designs will come through decreasing amount of protocols. So we're migrating towards a SAR from MPLS and then to the SAR-v6. There will be some hierarchical designs which also simplify the implementation and troubleshooting of this network infrastructure. But another thing which I want to talk here, which relates to this enabling simplification, is actually the network slicing is another concept which we're proposing within the cloud metro vision. And probably in the 5G world, the network slicing raises relatively naturally. So for example, there is a case we need to stitch the 3GPP slices to the slices of the network infrastructure. In the broader use cases may not so obvious, but if we take some retrospective view back into some dark times when the operator may be in possession of the multiple physical infrastructure, one infrastructure used to provide some particular use case or particular type of connectivity. So this thing used to be simple, but very costly. And at those times, the industry passed through transformation towards the single physical infrastructure, where the all type of connectivity converge on top of the same packet switch network. And well, that's pretty much the stage where we are right now. So the total cost of ownership, or the high total cost of ownership problem have been solved. But that's where the complexity was introduced. And from this perspective, they're introducing the set of abstract layers might be a very natural step to be implemented, deployed in the network. So it preserves the older concept of having the single physical infrastructure with the virtualized layers of networking, which also introduces the ability in a simpler way to provide a differentiated class of service to different types of traffic flows, and traffic flows belongs to then generated by different applications, of course, right? So this is about the network slicing, and we need to jump to the automation. And actually, the network slicing by itself is not the feature or function of the transport infrastructure only, and it's probably not possible to deploy it without the automation complex. And here we prefer to talk about the closed-loop automation, which is another principle inherited heavily from the cloud networking, right? Which in most cases are highly automated. Who automates it is a different question, actually. So for now, we're able to demonstrate very practical examples of closed-loop automation, which is based on collecting and analyzing data from the network, which comes from the all different source, and then loop it back through the actions of changing some traffic engineering policies, like in this example. But maybe the actual value of this closed loop automation concept will come when we introduce also as AI algorithm as working as part of those closed loop automation story, right? And the whole loop starts with the provisioning or intent-based provisioning, which is just the beginning. The real value is actually of AI comes, as per our opinion, when it comes to troubleshooting, right? So the formula for the future networking in this concept is continuously measure the user experience, continuously measure the network service quality through the embedded service assurance mechanism, and compare it with the other patterns and anomalies which the AI can derive through analyzing of big data, and finally come up with recommendations about the root cause problem. We believe that it will happen way faster than in certain cases we have to spend on troubleshoot our networks as of today, and that would be the true and very powerful step towards the, I say, more sustainable operations in this space. All in all, this is part of the concept and part of the vision for this cloud metro. All in all, we are pretty much in the stage of the honeymoon with AI, when the world is rosy and everything is possible. At some point in time, we probably will see how the closed-loop automation will allow to fix us directly the problem in the network, but yeah, we'll see. So the AI is powerful in fixing things, as creating a harm to your network, definitely. But definitely we can leverage for some analysis in the network. Sorry. Okay, and just the last slide to conclude on a little bit expanding the concept of the cloud metro vision beyond only those concepts which can be inherited from the cloud. So it comes to us to three major areas: operations, systems, and architecture. Automated and programmable operations and IP service fabric, as I said, were inherited from the cloud. And when it comes to the systems or routing system, which actually constitute the network, so that's obviously one of the most important component here. And to transform to the newer metro infra, we knew a new set of platforms which are cost optimized, which are feature rich, which are power optimized, and which can sustain the traffic growth in this segment of the network for a very, very long time. So the longevity of those new platforms being placed in the network should span up to the 7 or 12 years, according to our idea. And this is way higher than what we saw in the past in the same segment. And probably, once again, to repeat, the major goals here for this cloud metro is to implement and simplify the network deployment and network operations, because the level of complexity is really, really high. And that's something that will allow us to enable new types of better experience for two major stakeholders in this picture, which is the end user and service provider, for sure. And just by the way, since the sustainability goes as a red line through all the event, I should say that the steps in this diagram represent every one step brings you closer to the cloud metro, and also contributes into one aspect of the operational sustainable network, which would be either a business growth or people, or trying to build a more greener company or more greener network. So all in all, this is everything I have for you today. Thank you very much for your attention.